Hello, ladies and gentlemen. My name is Mr. Bryce. I'm with Susquehanna Valley High School here in Conklin, New York. There's my contact information. Today, we're going to be talking about mindful manipulations and solving equations. Standards are A, REIA, explain each step when solving an equation, and A, SSE A1B, fluency in transforming an expression. This is mindful manipulation. So let's take a look at it. We are on page 92 of my handout book. If you are using the modules, we're in Module 1, Lesson 12. Okay, so the first thing that we're going to take a look at is answer the following question. What does it mean by answer? It means think about, contemplate, why should the equations x minus 1 times the quantity x plus 3 equals 17 plus x, and x minus 1, x plus 3 equals x plus 17 have the same solution set. And the first time that you read it, you may say, is there any difference between these two? And that's exactly why we should say, why should they have the same solution set? Because we notice that we have x minus 1 in the beginning. We have x plus 3. Okay, so the first part of the equation looks exactly the same. It's the second part of the equation, or the answer, that looks different. So take a second and write down why they are the same. And if you wrote down the fact then you are right. It's the commutative property of addition. We commuted, or we changed the order of one small part of it. Now, question B, why should the equations, same equation, x minus 1 quantity times the quantity x plus 3 equals 17 plus x, same first equation set, second set. Oh, there's the difference. Do you see it? X minus 1 comes first, and x plus 3 comes first in that. They commuted it, except this time the commutative property is of multiplication. We have to look at things as parts. Okay, that's one part. That's another part. Don't look at just the x, don't look at just the 3. So that's what we got to do. We got to look at the thing as pieces. Like when you're looking at the bed in the morning and you have to make it, you're not looking at it as each individual piece. You're looking at the whole thing. I've got to make the sheets, make the comforter, make sure the pillows are in the right place. But you want to look at the whole thing when you're done to make sure that it's correct. Now, do you think the equation x minus 1 times the quantity x plus 3 equals 17 plus x, and the equation x minus 1 times the quantity x plus 3 plus 500? Let's see, that's a little different. Okay, and then we have equals 517 plus x. Should that have the same solution set? And why? So what did we do here? So it appears that we still have x minus 1 quantity times x plus 3. But then we have an intruder here. We're adding 500. And then this side doesn't look too much the same. We still have the x's, but oh, look at that. We added 500 to that side. So that is what property? The addition property of equality. When you add the same number to both sides, we added 500 to both sides of the equation. That's the addition property of equality. So D, do you think the equation is x minus 1 times the quantity x plus 3 equals 17 plus x, and okay, now all of a sudden we're tossing some more stuff in. Talk to the person next to you and see what's going on here. Okay, now we see that this is 3 times bigger, but remember, don't try to distribute that. No, 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 no. We're going to compare apples with apples, okay? And there's a Macintosh apple, and there's a Macintosh apple. There's a Granny Smith apple, and there's a Granny Smith apple, okay? Now, here and there, we can see clearly with the x and the 3x that it's 3 times larger. This is 3 times larger here as well. Okay, so if I multiplied the left-hand side by 3 and multiplied part of the right side by 3, oh, hang on a second. What's 17 times 3? 51. So it looks like that I distributed 3 on the right-hand side. I multiplied 3 to the right-hand side of the equation and got that. And I didn't distribute it on the left-hand side of the equal sign. So I multiplied both sides by 3. Should they have the same solution set? Yes, because the multiplication property of equality. If I multiply the left-hand side by a number, I have to multiply the right-hand side by the same exact number. If I divide the left-hand side by a number, I have to divide the right-hand side by exactly the same number. And I am going to erase it, so make sure you hit pause if you haven't gotten it down. Gone. You can rewind if you missed it. So those were just an opening exercise. Exercise 1. Use the commutative property to write an equation that has the same solution set. Lots of ways to do this. Okay? There's at least 6 answers that I can see immediately. You write down one answer, hit pause, write it down. Okay. Now, it doesn't say if we have to use the commutative property of addition or the commutative property of multiplication. If you wanted to commute those two, we could have had an x squared plus 4 minus 3x. We could have had a negative 3x plus x squared plus 4. Remember, the negative sign or the minus sign stays with the 3 when you move that around. And if we take a look at the right-hand side, we could have brought that 5 in front if we wanted to. X plus 7, and then x minus 12. Or if we didn't want to do that, we could have commuted the x minus 12, x plus 6 times the 5, or you could have put the 5 in the center. There's lots of ways to do this. So like I said, there's at least, I just gave you 4, but there's a lot more. If you have any questions, if your answer is right or wrong, raise your hand now. We'll go over it. And these are gone. Use the associative property to write an equation that has the same solution set. Okay. Associative property. Go ahead, hit pause, write down your answers. There are not a lot of answers for that. So for the first one, I associated the x squared minus the 3x. You can't associate the 3x and the plus 4. No, 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 no. Okay, so don't do that. On the right-hand side, the associative property of multiplication, I can multiply the first 2 times the third, or I can multiply the second and third first before multiplying it times the first term. Okay, so there it is. Does this reasoning apply to the distributive property as well? Think about that. So the way that I'm thinking about this reasoning is, can I make the problem look a little different and still be exactly the same? Yes. What I did was I multiplied the second and third terms together, distributed the 5 through the x minus 12. So that is what I said. The reasoning, you can make it look different, a mindful manipulation, if we wanted to look a little different. So now we're on the next page. Consider the equation x squared plus 1 equals 7 minus x. Verify that this has a solution set of 2, negative 3. Okay, now notice that there's only one variable in x, and notice that these are not in parentheses. I'm going to write this clearer for you. They are braces. So what that means is that you can substitute negative 2 in for both x's, not one x. You don't substitute you don't substitute 2 in for one of them and negative 3 in for the other. No, 2 has to go in for both of them. So when you write down the x squared plus 1 equals 7 minus x, we do 2 squared plus 1 equals 7 minus 2. The 2 went in both spots. Okay, so 4 plus 1, getting ahead of myself, is 5, and that equals 5. So 2 is in the solution set. Then you do exactly the same thing for negative 3. Why did I put negative 3 in parentheses? Because we're squaring it, and you always put an exponent in the base of an exponent in parentheses with the exponent outside so that we don't make any mistakes. Now notice that I have 7 minus negative 3. You can put negative 3 in parentheses. Don't do minus minus, do minus negative. So that is 9 plus 1, which is 10. This is 7 plus 3, which is 10. So it checks for both of them, yes. Draw the solution set as a graph on the number line. We'll later learn how to show that these happen only one solution set in the equation. And that's all we have. Draw it on the number line right there. We don't connect it, we don't shade in between it. It's just the number 5 and the number 10 on the number line. So now where are we going next? It says add 4 to both sides of the equation. So it's still talking about these equations. X squared plus 1 plus 4 has to equal 7 minus x plus 4. When we combine the positive 4 and the 7, we get 11 minus x. And on the other side, we get x squared plus 5. And there it is. Verify that 2 and negative 3 are still solutions by plugging them in. And there we go. I just did the math fast. And just to verify means just plug it in. If you need to copy it down, you can hit pause. But I'm going to erase it right now. Question C says add x to both sides of the equation. Okay, so here we're going to do x squared plus 5 plus x equals what? 11 minus x plus x. Those 2 went away. Wasn't that interesting? X squared plus 5 plus x equals 11. Wow. Well, was there a good reason to add x to both sides? Yeah. So you can have the variable on one side and the constant on another. Just for a mindful manipulation. Do you think 2 and negative 3 are still going to be solutions? Of course. Because the additive property of equality. We added the same thing to both sides. It doesn't matter whether it's a variable or a constant. Constant just means number. So, yes, they are still solutions. Write this down. Because of the additive property of equality. Now this is very important. Let's multiply both sides of the equation by 1/6. And which equation are we talking about? We're talking about a new equation, that one right there. So this is important because we're using the multiplicative property of equality, but more importantly, we're going to move between a fraction and a division symbol. Okay, so when we multiply x squared plus 6 by 1/6, not only do you get this part right here, but what I want you to be aware of is that it is also 1/6 times x squared is x squared over 6 plus 6 over 6, which is the same as x squared over 6 plus 1. Okay, so those are three things that we have to understand. It looks like that, it looks like that, and it looks like this. And then the fourth way looks like that. Are 2 and -3 still solutions? Yes, because of the multiplicative property of equality. If you don't believe me, you can check it out. Okay, out of these three examples, I want to briefly introduce you to B right now. This is a mindful manipulation. We notice that there is a number squared, s squared, and then there are no other variables with it. So through experience, we will realize that a number squared equaling a constant, that is what we want. So we take the square root of both sides. Now be very careful. We want to have the positive and negative square root of it, because not only can it equal +5, but it can also equal -5, because -5 times -5 is +25. I just want you to see that when we have a perfect square and no other s's or no other variable anywhere in the problem, we can do the mindful manipulation of getting the s squared by itself and taking the square root. This is where I want to get to. There are lots of ways to solve a problem. Consider the equation 3x plus 4 equals 8x minus 16. Solve for x using the given starting point. There are 4 different ways that you can solve this problem. Break up in your teams, and then we're going to assign, a group 1 is the first one next to the door, and keep on going around in teams. So we should have 2 people in group 1, and then around, and so on. And then once we get up to group 4, the next team is going to be group 1 again. Follow the directions, solve this problem. Once you've solved it, should every group have exactly the same answer? Is x exactly the same thing in each part? Talk about it. Shazam! We have exactly the same answer for all of them. This closing exercise is a nice mental manipulation. However, what I want you to do is I want you to turn to the next page after. Okay, if you're there now. If x is the solution to the equation, it will also be a solution to a new equation formed when the same number is added or subtracted from each side of the original equation. Okay, these are referred to as the property of equality. If one is faced with the task of solving an equation that is finding the solution set to the equation, you can use the commutative property, the associative property, the distributive property, and use the properties of equalities by adding or subtracting the same non-zero numbers if you're multiplying and dividing by non-zero numbers. In other words, you can't multiply something by 0 and expect you're going to get the same answer, or dividing by 0. We know we can't divide by 0, it's undefined. And you can keep rewriting the equation into a solution set that you can easily recognize. It's a mindful manipulation. Get it into something we can recognize so we know we can solve it from there. And the solution set will not change. If we commute it, if we distribute it, if we factor it, which is the opposite of distributing, and then we can get into something that we can chew on. Okay, we don't want to take the Whopper or Big Mac and take one bite out of it. We got to take little bites out. Okay, so we're on page 99, and our homework tonight is to solve problems 2 through 19. For those of you that like a challenge, you can also do number 1. But I want to see tomorrow problems 2 through 19 on page 99 completed. Have a great day.